Tonight, we're going to drift beyond the Milky Way. This is a calm, slow space documentary, made for sleep and for anyone who just wants to relax, while the universe quietly unfolds in front of them. Before we begin, take a moment to get comfortable. You might be lying in bed, or resting in a chair, or simply listening with your eyes closed. Let your body find a position that feels easy and safe and supported. You don't have to hold yourself up. Let the bed, or the chair, or the sofa carry your weight for you. If you like, you can take a slow breath in, gently, and then exhale, without forcing anything. There's nothing you need to do, and nowhere you need to go. For the next while, we're just going to float together through a very quiet universe. In your mind, imagine that you are far above our galaxy, the Milky Way. You are weightless, perfectly still, surrounded by dark, calm space. Below you, there is a soft, glowing disk of light, a spiral of countless stars, slowly turning on a timescale so long that, to you, it looks almost completely still. You don't have to focus hard. You don't have to picture it sharply. Just a gentle impression is enough. A pale band of light, curved in the dark, hanging quietly beneath you. You are floating, the galaxy is turning, and everything is peaceful. The Milky Way is our home galaxy. Somewhere inside that spiral of light is a small yellow star, and orbiting that star is a little planet covered in oceans and air, the place you know as Earth. If we think about our cosmic address, we might start with something familiar. You live on a continent, in a country, in a city or a town, on a particular street, inside one specific home. Now we can zoom out. Your home sits on the surface of planet Earth. Earth orbits the Sun. The Sun is one star in the Milky Way galaxy. The Milky Way belongs to a small family of galaxies called the local group, and that local group is just one tiny part of something even larger, a vast pattern of galaxies woven into what astronomers call the cosmic web. In this journey, we're going to drift slowly outward from our own galaxy into that larger structure, moving step by step, in no hurry at all. As we do this, there is one simple idea to keep in mind. When we look outward into space, we are also looking backward in time. The light from distant galaxies has been traveling for millions, or even billions of years, before it reaches us. So, when you imagine those galaxies, you're not seeing them as they are right now, but as they were when that light began its journey. You don't need to remember any numbers. You don't need to solve anything. Just let the thought drift past. As distance increases, so does the age of the light we see. Space and time are gently connected. Now, let's settle for a while on a simple question. What is a galaxy? A galaxy is a huge collection of stars, gas, dust, and dark matter, all held together by gravity. You can think of it as a city of stars floating in space. In a city, you have buildings and streets, and lights scattered across a map. In a galaxy, you have stars and planets, and clouds of gas, spread across a vast region of space. The Milky Way, our home galaxy, contains hundreds of billions of stars. That number is so large that it's hard to imagine. So instead of trying to picture every star, you can simply think of the Milky Way as a wide, glowing disk, filled with tiny points of light. In the center of the galaxy, there is a crowded region called the central bulge. There, stars are packed more closely together. There is more light, more activity. Surrounding that central bulge is a thin disk, where long spiral arms wind gently around the center, like slow streams of starlight, curving in the dark. Our sun is not in the center. It lives in one of these spiral arms, far from the crowded core, in a calmer neighborhood, out toward the edges of the disk. If you imagine the Milky Way as a vast, glowing city, then the central bulge is like a bright downtown, and our solar system is more like a quiet suburb. Farther out, above and around the disk, is a halo, a more diffuse region, where old stars and clusters quietly orbit and where a large amount of dark matter is thought to reside. Dark matter doesn't emit light. We don't see it directly, but its gravity shapes the galaxy, helping to hold it together and influence how it spins. From where you're floating now, high above the Milky Way, you see the whole structure at once. The bright central bulge, the thin, flat disk, the gentle spiral arms, and the faint halo around everything. It is one galaxy among many, one city of stars, quietly turning in an enormous dark. Take a slow breath in and breathe out as you let that image settle in your mind. Now, we drift back a little farther. As you move away from the Milky Way, the spiral of our home galaxy begins to shrink in your view. It becomes a small, bright whirlpool, a single piece of light in the dark around you. As you float outward, another spiral shape comes into sight. This is Andromeda, our nearest large galactic neighbor. Andromeda is a little bigger than the Milky Way. It, too, is a city of stars, with its own spiral arms, its own stars and planets, its own possible worlds. The Milky Way and Andromeda are part of the same small family of galaxies. Astronomers call this family the local group. If you look around now, you can imagine a few dozen galaxies spread across the space around you. Some are large spirals, like the Milky Way and Andromeda. Others are much smaller, faint, irregular clouds of light, called dwarf galaxies. Dwarf galaxies orbit the larger ones, like small towns, on the edge of a big city's influence. The entire local group is held together by gravity. The distances between these galaxies are vast, yet compared to the rest of the universe, this little group is a fairly small, local structure. Andromeda and the Milky Way are moving very slowly toward each other. Over billions of years, their paths will bring them together in a long, slow collision. The word collision might sound violent, but in reality, the space between stars is so great that when galaxies merge, most stars simply pass by one another without hitting anything. Instead of a sudden crash, it's more like two large, glowing clouds drifting through each other, their shapes changing over time. Many stars will simply find themselves orbiting in a new pattern within the merged galaxy. This entire process takes hundreds of millions or billions of years, much longer than a human lifetime, or even the lifetime of an entire human civilization. It's a slow dance, set to the tempo of gravity, played out on a cosmic stage. You don't need to worry about it. You don't need to keep track of the timescales. For tonight, it's just a gentle thought. Two galaxies floating toward each other so slowly that, from your perspective, they might as well be still. You're hovering now in the space between them, watching the Milky Way on one side and Andromeda on the other, surrounded by smaller dwarf galaxies, like scattered fireflies. The local group is your neighborhood, quiet, faintly lit, resting inside a much larger universe. Let's drift farther still. As you move away, the Milky Way, Andromeda, and the other members of the local group begin to gather together in your view, into one small cluster of lights. They become a single patch, a tiny island, in the darkness. But as you continue to pull back, you start to see other islands, other groups of galaxies, spread across space. Some are close, some are very far away, but together they form a larger structure called a cluster of galaxies. A galaxy cluster is like a great city in the universe, where before you saw a handful of galaxies in the local group, now you see hundreds or even thousands of galaxies bound together by gravity. Some of them are large spirals, like the Milky Way. Others are smooth, more rounded shapes, called elliptical galaxies. Many are small and faint. Between these galaxies is very hot, thin gas that fills the space in the cluster. You wouldn't feel it as hot because it is incredibly diffuse, spread out over huge distances. But measured by its temperature, this gas is extremely energetic. Hidden within and around the cluster is a large amount of dark matter, invisible mass, whose gravity helps keep the cluster together. From your vantage point, none of this is stressful. You simply see a swarm of soft lights hanging in the dark. If the local group was a neighborhood, then this galaxy cluster is like a wide metropolitan region. Many neighborhoods linked together. You float slowly through it, passing one galaxy after another. Each one, in reality, is unimaginably far from the next. But in this calm mental view, you can let them appear a little closer, like distant streetlights, seen from above at night. Nothing rushes, nothing collides. Gravity works on its own slow timescale, quietly shaping the cluster over billions of years. Now, we continue our journey outward. As you move away from this cluster of galaxies, it shrinks into a bright patch, a glowing knot of lights. And then you notice that it is not alone. All around you, other knots of galaxies begin to appear. Some are closer, some are farther, and faint threads of light seem to connect them. These larger patterns are called superclusters, regions where clusters of galaxies are more common, forming vast structures over hundreds of millions of light years. If a galaxy is like a city and a cluster of galaxies is like a metropolitan area, then a supercluster is like an entire continent. Multiple superclusters and clusters and groups of galaxies are arranged together in a pattern known as the cosmic web. In this web, matter is not evenly spread out. Instead, it forms long filaments, stretched regions, where galaxies are more densely packed, and these filaments intersect at nodes, where large clusters reside. Between these filaments are immense empty regions, called voids, where there are very few galaxies at all. From your calm perspective, floating far above this structure, the universe looks like a delicate three-dimensional network of light and darkness. Thin strands of galaxies trace out the lines of the web. Bright knots mark the intersections, and in between, there is deep, quiet space. You don't have to hold a perfectly clear image. It's enough to feel that the Milky Way, your home galaxy, is just one small point. Somewhere in this vast pattern, now we can begin a slow, continuous zoom. Start again. Just above the Milky Way, you see a single spiral galaxy. Beneath you, its arms curling softly in the dark. You drift upward. The Milky Way grows smaller, and another spiral appears. Andromeda. Soon, you see more faint shapes, dwarf galaxies, and the whole local group comes into view. You keep moving back. The local group shrinks to a cluster of points. Around it, other groups of galaxies begin to appear, scattered through space. Together, they form a larger cosmic city. A galaxy cluster you drift farther. The cluster becomes a bright patch, one knot, among many others. Filaments of galaxies connect the knots, forming long strands that reach across enormous distances. You are now seeing a part of the cosmic web where clusters, groups, and individual galaxies all trace out a grand structure. For a moment, just rest here. You can imagine yourself suspended in the dark, with the cosmic web spread out around you in every direction. Every point of light is a galaxy. Every galaxy contains many stars, and around one of those stars is a small planet, where you are lying now, listening to this, breathing slowly. Across all these scales, from your room to Earth, to the solar system, to the Milky Way, to the local group, to clusters and superclusters, and the cosmic web, one thing remains true. Right now, in this moment, you are safe, and still, you can let the vastness make your own concerns feel a little lighter, a little more distant. If thoughts arise, you can let them drift past, like galaxies in the distance, not pushed away, just allowed to move on at their own gentle pace. As you float here, surrounded by clusters and filaments of galaxies, let's gently think about how we measure these enormous distances. Astronomers often use a unit called a light year. A light year is not a measure of time, it is a measure of distance, the distance that light travels. In 1 year, light moves incredibly fast. It can circle the Earth many times in just 1 second. But even at that speed, it still takes time to cross the vast stretches of space. So when we say a galaxy is millions of light years away, we're really saying that the light we see from it has been traveling for millions of years through the dark to reach us. Imagine a single beam of light leaving a star in a distant galaxy. It travels, straight and patient, through empty space, year after year, passing clusters, passing filaments, crossing the quiet voids. Eventually, after perhaps millions or billions of years, that beam of light reaches a telescope near a small planet, orbiting a star in the Milky Way. By the time it arrives, the place it came from may have changed. Stars may have moved. New stars may have formed. Others may have faded. What we see is not a live broadcast. It is an ancient message. In a sense, every time we look out into deep space, we are looking into the past. If you look at the moon, you see it as it was about 1 second ago. If you look at the sun, you see it as it was about 8 minutes ago. When we look at nearby stars, we often see them as they were years in the past. And when we look at distant galaxies, we may be seeing them as they were millions or billions of years ago. You don't need to remember any of these numbers. You can simply rest with the idea that in the universe, distance and time are deeply connected. The farther away an object is, the older the light we receive from it. Our telescopes are not just instruments of sight, they are also time machines collecting ancient light that has been on a journey for longer than any human memory. As you float in this calm, dark space, you can imagine those streams of light flowing toward you from every direction. Each beam carries a snapshot of the universe at a different moment in its long history. Some beams began their journey when the Earth was young. Some started on their way before our sun existed. Some left their home galaxies when the universe itself was still forming. its large-scale structure. Right now, you don't need to sort them out. You don't need to label them. You can imagine them simply as soft, gentle threads of light, all arriving together, quietly, bringing with them the story of the cosmos. If you'd like, take another slow breath in and a slow breath out, and let any tension drift away with each exhale. The universe has been unfolding for billions of years. Tonight, you are allowed to fully rest for a little while inside that story. Now, let's travel back in our imagination to a very early time in the universe's history. Not to the very first instant, but to a time when the universe was still hot and dense, filled with a smooth, glowing mixture of particles and light. In that early universe, matter was spread out almost evenly. There were no stars, no galaxies, no clusters yet, just a nearly uniform sea of tiny particles and radiation. But almost evenly is not perfectly evenly. There were tiny differences, very small regions that were just a little denser than their surroundings, and other regions that were slightly less dense. These tiny differences were the seeds of everything we see today. Where there was a little more matter, gravity had a little more strength. Over time, these slightly denser spots pulled in more material from their surroundings. They grew slowly, almost imperceptibly, forming clouds of gas and dark matter. The process was patient and gradual. Imagine a vast, dimly glowing fog with soft ripples across it. The denser ripples begin to gather themselves, pulling in more matter, deepening into clumps. Inside those clumps, gas clouds eventually become dense enough and hot enough for the first stars to ignite. These first stars were very different from our sun, often massive, bright, and short-lived. They flooded their surroundings with light and radiation. They lived fast, then ended in powerful explosions called supernovae, sending heavier elements out into space. As time went on, more and more clumps of matter formed. They merged, collided, and settled into rotating structures that would become the first small galaxies. At the same time, there was something else helping this process along. Something invisible. Dark matter. Dark matter does not emit light. We don't see it directly, but it has mass, and it feels gravity, and it forms its own large-scale structures. You can imagine dark matter as a hidden scaffolding spread throughout the universe, a network of invisible hills and valleys in the gravitational landscape. Ordinary matter, the kind that makes up stars and planets, and you, tends to fall into these valleys, where dark matter forms a dense region. Ordinary matter collects there too, cooling into gas clouds, forming stars, and eventually building galaxies. Over billions of years, small galaxies merge and grow, combining their stars and gas to become larger systems. Some become spiral galaxies with graceful arms. Others become elliptical galaxies, more rounded and smooth. All the while, the larger pattern of the cosmic web is being drawn out. Filaments of dark matter and galaxies, nodes where clusters form, voids where little matter collects. From your quiet vantage point now, you can imagine this whole history playing like a very slow, very gentle film. The early, almost uniform universe, tiny fluctuations forming, gravity pulling matter into clumps, the first stars lighting up, small galaxies forming, merging, growing, weaving themselves into the web of structure you see today. You don't need to follow every step. You can simply feel that the universe has been patient. It took a very long time for the Milky Way to become what it is. It took a very long time for the stars that would eventually build planets and life, and you, to form. The atoms in your body, the calcium in your bones, the iron in your blood, the oxygen in your lungs, were made in stars and supernovae long before Earth existed. You are, in a very real sense, made of star material assembled over billions of years by the slow work of cosmic history. As you rest here, you can let that thought be comforting. The universe has taken care of the details for a very long time. For tonight, you don't need to do anything but breathe and drift and allow yourself to be carried by the same gentle laws that guide the stars. Now, let's think softly about one more important idea: the expansion of the universe. When we say the universe is expanding, we don't mean that galaxies are rushing outward through a pre-existing space, like fragments from an explosion. Instead, it is space itself that is stretching. A classic way to imagine this is to think about raisins in a loaf of bread. Imagine a ball of dough with raisins mixed in. The raisins represent galaxies. The dough represents space. As the dough rises, it stretches. The raisins don't need to move much on their own. They are carried apart because the dough itself is expanding. From the point of view of any one raisin, it looks as though all the other raisins are moving away in every direction. The farther away another raisin is, the faster it appears to move away, because there is more dough between them that is stretching. Our universe behaves in a similar way. Space is gradually expanding, and on very large scales, this expansion carries galaxies apart from one another. On smaller scales, within galaxies or within galaxy clusters, gravity is strong enough to hold things together. But on the largest scales, the expansion of space dominates. This expansion has a subtle effect on the light traveling through space. As light moves across the expanding universe, the space it travels through stretches. When that happens, the wavelength of the light is also stretched. Longer wavelengths correspond to redder light, so distant galaxies often appear more redshifted. Their light has been stretched toward the red end of the spectrum by the expansion of space. Astronomers measure this redshift to estimate how far away galaxies are and how fast the universe is expanding. You don't need to hold on to the details. You can simply picture a beam of light as a wave with peaks and valleys. As the universe expands, those peaks move farther apart. The wave becomes gentler, more stretched, more red. Now, let's consider how far we can see. Because light takes time to travel, and because the universe has a finite age, there is a limit to how far away we can observe. This limit is called the observable universe. It's like a horizon. When you stand on a beach and look out to sea, you cannot see forever. The curvature of the earth and the thickness of the air set a limit to your view. In a similar way, we cannot see into regions of the universe so distant that their light has not had time to reach us since the beginning. Beyond that horizon, there may be more galaxies, more clusters, more web-like structure, but their light has not arrived yet and may never arrive. If the expansion of the universe continues to accelerate, surrounding us in every direction is a spherical boundary of what we can, even in principle, observe. We are not at the center of the entire universe. We are at the center of our observable patch, a bubble defined by how far light has had time to travel to us. And every galaxy has its own observable universe, its own bubble centered on itself. From your peaceful place in the dark, you can imagine this observable universe as a soft, faintly glowing sphere around you. Inside it, you see galaxies, clusters, superclusters, and filaments, traces of very ancient light. The afterglow of the early universe itself gently fill this sphere like a faint background. Outside it, there may be more of the same, stretching on and on. Or the universe may have some shape and structure we do not yet understand. We don't know for certain, and that's all right. Some questions are still open. Some mysteries are still mysteries. For sleep, you don't need to solve anything. You can simply rest with the feeling that the universe is vast, that we see only a part of it, and that even within this observable sphere, there is more than enough wonder to last a lifetime. Now, if you're still awake, still floating with me, out here in the dark, we can begin a slow, gentle journey through the universe itself. If you've already slipped into sleep, that's perfectly fine. These words can simply become a soft background, a distant murmur, folded into your dreams. But if you're still listening, imagine once more that you are weightless, suspended in space. All around you, the cosmic web is spread out, like a faint, three-dimensional lace, made of galaxies and light. Bright knots mark the places where galaxy clusters sit. Thin filaments stretch between them, delicate strands, where galaxies line up like beads on invisible threads. In between these filaments are the great voids, immense regions with very few galaxies at all. Quiet, dark, spacious. You're floating near one of the filaments now, just outside a bright knot of clustered galaxies. Take a moment to picture it or simply feel it. You don't need a sharp, detailed image. It can be soft, almost like a memory, a glow in the dark, a cluster of lights, a sense of structure around you. You begin to drift along the filament. There is no engine, no rocket, no sound. You move the way clouds move across a calm sky, slowly, almost imperceptibly. As you travel, you pass one galaxy after another. Some are graceful spirals, their arms curling gently like ghostly pinwheels. Some are rounder, more diffuse, like soft smudges of light. Every galaxy contains billions of stars. Every star might have planets. Every planet is a world with its own history, its own possibilities. But from here, they are all just tiny points of light. In the distance, you don't have to wonder what's happening on each world. You don't have to imagine every detail. It's enough to know that they exist. Countless possibilities spread across an immense, quiet universe. As you continue along the filament, the galaxies around you drift slowly by. Some appear closer, like bright lanterns over a vast ocean. Others are faint, like distant ships on the horizon. The pace is so slow, so gentle, that you might almost feel as if you're not moving at all. But over long stretches of time, you are crossing enormous distances, millions of light years, then tens of millions. then more. You may notice how your breathing has settled into its own quiet rhythm, in and out, like the gentle motion of this imagined journey. The cosmic web does not hurry. It simply exists, its filaments and nodes holding their shapes over billions of years. You, too, do not need to hurry. You can take all the time you need to drift, to rest, to let your thoughts grow slow and soft. Eventually, you approach another bright knot in the web, another galaxy cluster. You glide near its outer edges, where individual galaxies are spaced like lanterns at the edge of a town. If you were to look closely, you would see stars being born in glowing clouds of gas and others fading, growing dim as their fuel is used up. But from here, you only see the overall pattern, a collection of lights, a city of galaxies hanging quietly in the dark. You drift around the cluster, then gently past it, back into the quieter stretches of the filament. You are a calm traveler in a very calm universe. As you continue your journey, following the filament outward, you begin to sense how large your observable universe is, and also that it has a limit. You travel and travel, but everything you see still lies within that great sphere of visibility, the region from which light has had time to reach you. Imagine, if you like, that you can see faint lines of light showing the paths that photons have taken over billions of years to arrive here. They come from all directions, from nearby galaxies, from distant clusters, from the soft afterglow of the early universe itself. The farther you look, the older these messages of light become. There comes a point where the galaxies you see are very young, where the universe was less structured, less organized, more chaotic and bright. Beyond that, there is a veil, not a solid wall, not a barrier in space, but a limit set by time. Beyond that limit, light has not had enough time to reach you. You can imagine this horizon as a kind of soft, glowing fog surrounding your view, not frightening, not sharp, just a gentle transition from the region you can see to the region you cannot. What lies beyond? It may be more of the same, more galaxies, more clusters, more filaments and voids, extending farther and farther in every direction. Or perhaps the universe as a whole has a shape, a curvature, a structure that we don't yet fully understand. Perhaps space is finite, or perhaps it is unbounded. We don't know. And right now, you don't need to know. You can let these questions float unanswered, like soft clouds passing across a calm sky. There is also the mystery of dark energy, a name we give to the cause of the universe's accelerated expansion on the largest scales. Space is not just expanding, it is expanding faster and faster over time. We don't yet know exactly why. We see its effects in the way galaxies move apart from each other, in the way light is redshifted, in the way structures evolve. But the underlying nature of this dark energy is still unknown. And again, that's okay. The universe does not require us to fully understand it before we rest. Mystery is not something we have to fight. It can be something we gently accept. As you float here, near the edge of your observable universe, you can let these big questions remain big and distant and quiet. You don't have to solve them. You don't have to carry them. You can simply acknowledge them, the way you might notice distant mountains, on the horizon, beautiful, unknowable in detail, and perfectly fine, just as they are. Feel your body, where it rests. Notice the weight of your arms, your legs, your head. Notice the contact with the bed or the chair, even as your imagination travels to the outer limits of what we can see. Your physical self is safe and still in one small, familiar place. You are not lost. You are not drifting alone. You are held by gravity, by the surface of the earth, by the warmth of your surroundings. The universe is vast, but you have your own small, steady corner of it to rest in. Now, very gently, we're going to begin the journey home. There's no hurry. Time in this imagined space can stretch as much as you like, but the direction is slowly turning inward from the outer reaches of the observable universe back toward the place you began. You turn around, so to speak, and look back inward along the filament. Far away, you know that somewhere toward the center of your view is the Milky Way, your home galaxy. You begin to drift back. Along the way, the cosmic web reveals its structure once more. You see bright knots, galaxy clusters, connected by thin strands of galaxies and dark matter. You pass near one node, then another, each one a huge collection of galaxies, quietly turning under the pull of gravity. As you move closer to the region that includes our own local group, you might imagine a soft dimming of the far-away structures behind you. The universe doesn't actually dim this way for a traveler, but in this gentle visualization, it can help your mind let go of all that vastness. For a moment, the brightest lights are now the ones closer to you. Clusters give way to smaller groups. Superclusters fade into the background. You find yourself near a familiar region, our own collection of nearby galaxies, the local group. From here, you can see the Milky Way, Andromeda, and many smaller galaxies as points of light surrounding you. You drift closer to the Milky Way. It grows slowly from a tiny spark into a recognizable spiral disk. You see its central bulge, its extended arms, the thinness of the disk. When viewed from the side, you move toward one of those arms, the one in which our sun resides. Stars to begin to separate. In your vision, what once looked like a smooth band of light is now made up of countless individual points. You drift into the calm suburbs of the galaxy, far from the crowded center, in a spiral arm where stars are spaced apart in quiet orbits. Somewhere here is a star we call the Sunday. As you approach, you begin to notice a faint, dim ring around this star, a planetary system, small, rocky worlds, close in, giant, gaseous worlds. Farther out, asteroids, comets, dust and ice, ranging through space. You move closer still, toward the third planet from this star, a world covered in blue oceans, white clouds, and the soft brown and green of continents. Earth. You drift down toward it, seeing first the whole sphere, then the curve of its horizon, then the shapes of land and water. Clouds move slowly across the surface. Storms swirl in broad, white spirals. But where you are going is calm. You pass through the upper atmosphere, through the thin blue layer that protects life below. You descend toward the surface, toward a specific region, a particular city or town, a neighborhood, a building, a room, and in that room you see yourself, lying down or resting, breathing slowly. For a moment, you can imagine looking at yourself with the same quiet perspective you used to look at galaxies. You see a person who has experienced much, who has thoughts and worries and hopes, a small, complex universe, all their own. You feel a sense of gentleness toward that person. They have done their best with the time and information they have had. They have carried many things on their mind, and now they deserve rest. You merge with that perspective, no longer observing from above, but once again feeling from the inside. You are back in your own body, aware of its weight, its warmth, its contact with the bed or chair, but something in you remembers the immense scale you just traveled through, from the edge of the observable universe to the cosmic web, to clusters and groups, to the Milky Way, to the solar system, to Earth, to this room, to this single breath. You have come all the way home. Now, there is nothing more you need to understand. You don't have to remember the names of structures or the numbers for distances and times. You don't have to hold on to any specific image of galaxies or clusters or the cosmic web. You can let it all fade into a gentle blur, like stars seen through half-closed eyes. All that remains is a feeling of vastness stretching outward in all directions, a feeling of quiet order, of slow, steady change over unimaginable time, a feeling of your own smallness, not as something frightening, but as something freeing. Your worries, your to-do lists, your unfinished tasks, all of them are very small compared to the age and size of the universe. They still matter, but they can wait for another time. Right now, the only thing that matters is rest. Feel the rise and fall of your chest, in and out. If you notice any tension in your body, in your forehead, your jaw, your neck, your shoulders, your hands, your legs, you can invite it to soften. You don't have to force it, just notice it and gently allow it to loosen a little. You are being held by the surface beneath you, by the gravity of Earth, by the quiet laws of physics that hold the planets in their orbits and the stars in their galaxies. The same universe that built galaxies and clusters has also built this moment of stillness for you. If thoughts arise, that's okay. You can imagine them as distant galaxies appearing at the edge of your awareness, shining for a moment, and then drifting away into the dark. You don't need to follow them. You don't need to push them away. You can simply let them pass. If sleep is ready to come, you can allow it to arrive whenever it likes. There is no need to try to sleep. Trying is effort. Sleep is the absence of effort. You can just rest, float, breathe, and let your mind grow quieter and quieter. The Milky Way is still turning slowly in the dark. The local group is still drifting. The cosmic web is still in place, its filaments and voids unchanged by a single night. On a small world, the universe will continue its long, patient story while you sleep. You are allowed to set everything down. For now, let your eyes grow heavy. Let your thoughts grow dim. If you are still listening, you can keep these final words as a soft, repeating thought. You are safe. You are small in a comforting way. You are part of a vast, quiet universe. that has room for you to rest. And as the galaxies turn in the dark, as the light of distant stars crosses the empty spaces, you can gently let go and drift and sleep